off of it. Really
Yeah,
fun.
I'm sure
I think
Jupiter looked pretty darn good.
I think this meeting is
Later.
happening, gentlemen. Hey, stargazers, telescopers, occulters, everybody, and a continued happy new year as we enter our third big week of the brand new year, 2026, for the SBAU Astro Hour. Wrapping up our fifth full year, kicking around this cutting edge cosmology. Every Monday morning, something these gents on the screen have Zoom with me, and I enjoy doing. We love talking about it. I'm your host, Ronnie Heron, one of the members of SBAU, which is the SBA Santa Barbara Astronomical Unit. Meets for our general meetings, our star parties, our Sunday sun gatherings, plus some time in the little planetarium of the Santa Barbara Museum of Natural History. Check us out, please, on sbau.org. And doggone, if you got questions or comments during our 1 hour, please leave them on the screen and maybe one of our members will check it out. Before we meet the crew, let's find out what we're going to talk about today. Deep sky observations this week without a significant moon. Open cluster NGC 7789 called Carolyn's Rose.
Yeah,
And
beauty.
we're going to talk about NGC 2237, the Rosette Nebula. Going to look at some supernova candidates. In fact, a lot of noises this weekend as this party focuses on the plain vanilla Novae. We check out a type 1A supernova, things that really go boom. How about the dreaded core collapse variety? How do you kill a nova? Well, you merge two neutron stars together. I hear. Going to focus on a red giant called Mira, the variable star in Leo, and get these concepts. We're going to kick around. Dark stars, like I guess, black holes in the early galaxy. Are you kidding me? The young universe, blue monster galaxies, and little red dots scattered everywhere. Now let's meet the crew. Good morning, Mr. President. Thank you, Jerry Wilson, for hitting year number 6 in about a month and a half.
Yeah, good morning, everybody. Good morning, my sister Joyce and my grandkids, Riley and Calvin.
And your lovely wife, the first lady of the club, Pat Forgy, is a listener and a supporter. Also married to a Pat is our incredible outreach coordinator, Chuck McPartland, who is everywhere. You know, have a telescope, we'll travel. Lenses are us. We are everywhere. Let me tell you, we're at hotels and county city parks, actually state parks. And anyway, Pat McPartland is his wife, merchandise manager, and also treasurer. Well, let's see. Tim Crawford joined us. His wife is Karen. Hiya, Tim.
How do you do?
I join you guys tomorrow night on the screen for the workshop. Will you be on board?
Yep.
Okay, and he's working on a dynamite December speech, 10.5 months away. I can't wait. I gave you some suggestions. We'll see what you come up with. December is our in-house members only. And Karen is his wife, and doggone if Tom Whittemore is not with us. Hello, Tom.
Morning. Hello.
He works on the newsletter, gets it right out on time, and has forever. He will till he dies. Just like me being on Warfare, you're going to be on duty as a newsletter editor.
And a mere expert.
That's right. But you kind of miss those Bunsen burner days of the electrical lab at Westmont, don't you?
So we never had Bunsen burners because of the gas.
It's an electrical.
No,
I've never heard of an electrical lab.
that's
You got to be careful in there.
That's more in the chemistry realm, you know.
Oh, it's a chemistry.
Yeah, I taught physics, electronics.
Yeah, I wish I'd taken chemistry. And Maureen, how's wife doing?
Oh, fine. She's out with Wally, the dog.
Does she ever go out with you with a pair of binoculars, bird watching?
Oh my gosh, yes.
Really?
Yeah.
You're both members of the bird watchers, the Audubon.
Well, she's not in Audubon, but she loves birds, and I share the binoculars. Oh yeah, I do. I love birding, but you know, as we walk and hike with Wally, you know, point out stuff, and she really enjoys it.
Well, we lost Bruce Murdoch, so there's just 5 of us on the screen now, and so we're plunging ahead, and we always start with a little silliness. The boss man at the helm sends us his tunes of the week. Many of them are scientifically based. Some are just downright funny. Others are thought provokers. You're going to have to enlarge this, Jerry. Yeah, this is the one that I didn't figure out. It's Mad
So I did.
Magazine.
I did.
Okay, anybody want to explain that? Explain it to us, Tim.
Well, this is actually from Mad Magazine, and that's why I was very, very interested in this. Now let's see, you read it like a book, so they're going along on their lunar lander here on the lunar vehicle, and just driving along, and they get out of the lander and then go and look, and then finally they get on the way back, and they get back to the lunar lander, and all the wheels and stuff have been stripped off.
Oh, okay, I see it now.
So it must be part of LA.
Or the Brooklyn part of the moon. That's funny. What was that guy's name that did these crazy? There were several. There was Newman. Alfred E. Newman was the character's
Oh yeah.
face.
Yeah, what me worry? Right?
What we were.
Yeah, what
Oh,
we-
this one.
Alfred E. Newman.
Jerry, you want to explain this?
This is a scene, a frame capture from the movie Alien.
Oh.
And they have just come back from being on the planet infested with the alien, and they're having a meal.
Yeah,
Their
right.
colleagues, and this guy that's leaning forward, he's got an embryo growing in his stomach, and it's about to pop out. So
Well, you
They're-
talk about your atrial fibrillation. That guy has it.
Now I remember. Now I remember that guy.
okay,
But by the way, I watched that Dragon reentry
yeah,
because I was out for an asteroid. I was out by Rancho San Marcos Golf Course, and it was fabulous. The plume had to be 30 or 40 degrees long,
yeah.
and it went from horizon to horizon, and then about 3 minutes later, kaboom!
Wow.
Huh.
Yeah, it was the kaboom was 1:37 a.m. because it woke me up.
12:37.
Was it last
Yeah,
night?
12:37, yeah.
No. This was a couple of nights ago.
Yeah.
Oh, okay.
I sent
Oh.
everybody out a notice because I intercepted it on nextdoor.com of all things. Took a chance and reposted it, and Chuck told me I was right on, except for it wasn't the SpaceX crew.
It was yeah, they weren't a SpaceX crew. But
Yeah,
also that was when they splashed down. So the reentry was actually a little bit earlier. It was 12:33 to 12:36, something like that.
Yeah, the sonic boom comes about 5 minutes later.
Yeah.
We got a
Oh.
really nice rocket launch out there at Westmont too.
Yeah.
Westmont. Oh, you saw it out there?
Oh yeah.
Okay, who wants to unravel this one here? Well, I'll do it. The universe unfolding as it should, but as it's a fitted sheet, it's kind of impossible to fold it back up together again, isn't it? You ever tried to fold those damn things up with the corners tucked in? That's how the universe is. All right, Chuck, you want to explain this one? Crop circles?
Sure. Crop circle hoax revealed. So here's the alien using what the people on Earth do to fake these crop circles. He's got a board and a couple of ropes and a stake, and he's
Oh,
flattening
now I
the crops in a circle.
You can hear that tone now from Close Encounters. Da, 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 da. Jerry, what are we looking at here? A couple of arguing dinosaurs.
Yeah, this is the world's first pointless argument. It's a comet. It's an asteroid. It's a comet. Asteroid. Comet. Asteroid. Doesn't matter.
Well, they could have seen it. Okay, here looks like these are a couple of aliens trying to book a room, right?
Yeah, there's their spaceship outside, and it's got smoke coming off of it. So they dropped into the local motel, and one of them says, "We're in luck, Zorko, because look, they take Uranus Express cards."
Pretty
That's
good.
right. Mine expired, thank God. I'm playing for the new Doug card. That's funny stuff. I love it. Okay, now that we're in the mood, let's go to the darkened sky and check out Planets Are Us. Inner, outer, whatever, opposition. Which my old radio voice is in the shop again. These damn loaders they give you, no good.
By the way, Tom, you were asking about Jupiter the other night, and when it
Yes.
was low, it was so soft you couldn't make out probably anything. But the
Oh, I
higher
see.
it got in the sky, the better and better it got. But the belts and zones now are very dim. They're very
I
light.
see. Yeah, and it's still, I think, in retrograde. I still think it's poking up into the twins. Uh,
Okay.
it's going to turn around soon, but yeah.
Okay, we're looking for normally when the moon is bright, we look for clusters, but here the moon is gone. I think it's a new moon.
Mhm.
So we're going to look at the Caroline's cluster, which is a faint cluster, but big. And it's right here in the center of this bullseye. It's near Calf in Cassiopeia.
Mhm.
And it's close to this time of year. It's in the northwest. It's about to set. Let's see, this is a time, what time is this? Does it say? Oh, that's up the other side. Yeah, this is 9 p.m. So it's
Mhm.
mid-evening. And you got probably 50 degrees, 40 degrees of height before it sets.
Yeah, that's such a beautiful cluster, Jerry. I used to pull it in at Westmont, the 8 inch, and
Uh-huh.
on a really, really crisp night, it would just scintillate. It's just really pretty.
Yeah.
Is it called Carolyn's Rose?
Yeah.
Yes,
Okay.
uh-huh.
And there's a reason for that? Not
It's
very
Carolyn
visible,
Herschel
so
described it.
A
yeah.
lot of these things, as you know, were named um, early in astronomy, observational astronomy history. So they were given names based on their visual appearance. So when you try and capture that with photos, it's not always the same. But
Mhm.
if you look here at the cluster, you can see there are little faint circular areas, dark areas that are gone. And it makes it, with a little bit of imagination, it looks like the curved petals of a rose, like you're looking
Yes.
straight down
Oh,
on it.
yeah, yeah.
Mhm. Yeah. And it's
well,
magnitude 6.7. It's pretty darn bright.
Yeah,
Is there an NGC number on that?
7789? Is that what you mean?
Yes, yes.
Hmm.
in the talking points.
Yep.
Yeah, I looked right at it. Forgot it.
I believe you said that the person who discovered it was named Carolyn. Did I misread that?
Yeah.
Carolyn Herschel, yes.
Herschel.
Okay.
She was the sister
Of
to
William Herschel?
yeah,
Yeah.
she used to make him sandwiches and stuff so he could keep grinding his mirrors.
Really?
Would feed him the
Feed,
sandwiches.
feed him, yeah.
It
And
invented
She
he
sandwich.
eventually came over from Germany. That's where Herschel was originally from, to England. Yeah.
The Earl of
and
Sandwich had invented that by then, I guess. Yeah,
and
sandwich.
he would be at the telescope and he would just call out when he saw stuff go by. It wasn't a driven scope. He would just look at a certain altitude above,
Yeah.
and as things drifted by, he would call them out and describe them. And she was at an open window with a candle and a book, and she would write down what he said.
Yeah.
And that's how they cataloged the sky.
And
Yeah.
those were speculum mirrors, weren't they?
Yeah.
Yes, yes, they were. Made out of metal.
He had every time
Metal.
they oxidized, he had to regrind it to get
Mhm.
a new
Did
Sort of
surface.
Herschel discover the last two gas giants?
Now
Yeah.
they started together what we call now the New General Catalog, or
Right.
NGC.
Oh,
Oh,
Well,
really?
he discovered Uranus from his
That's right.
backyard. Yeah.
Yeah.
1781.
so
1781. And his son John was just as good an observer.
got it.
Okay. John was the son.
Hmm.
I love the
I think
history.
John did a lot of work down in Africa, right, Chuck?
Yeah.
Yeah. He went down to Cape Town, and
Yeah.
in
This
fact,
one,
Mensa, the constellation Mensa, was
Ah,
basically memorializing that he had his observatory down there.
that's cute. Yeah, table.
He figured his dad had already covered the northern hemisphere,
Yeah.
so
next
he'd
next
see
chance we get, Tom, when we're out together, we're going to get that Carolyn's Rose for sure.
Oh, it's beautiful.
Yeah.
Yeah. It's a sparkler.
Now,
Okay.
also at 9 p.m. at night, you can get the constellation Orion, and down here, just off of Betelgeuse, down here is what's called the Rosette Nebula, and it's a what is
Another female astronomer.
a star birthing thing.
Mhm.
So star nursery.
With an embedded open cluster too.
Yes.
The star hop to that is really difficult in a way because there's
Yeah.
a real flat triangle and it's the apex, the very obtuse apex of one of the angles is the
Well,
If you look at it here from Betelgeuse to Procyon, this would be about halfway. It's close to halfway and just a little south of the line.
That's not bad. I kind of like that.
And right now, about 9 o'clock, it's really pretty in the east for people listening who, don't have a telescope or binoculars. You can just go out and look towards the east, and you see Procyon and Sirius, side to side, a long distance away, but really pretty.
Yeah, yeah.
But is this map totally accurate? Is every one of those little white dots a star that's actually there where it is pictured?
Yes.
Should be.
Yeah,
Wow.
it should be. Yeah.
This is a planetarium software program. It's called the Sky 6 or the Sky X. I forget which one I'm using for this. And it's made by Software Bisque, which is a very respectable company.
Well, you bet they have a.
Yeah, another one I use and I like a lot is Starry Night 8. That's a nice one.
Wow.
Sky Safari also.
hmm
Sky Safari really looks a lot like this.
Hmm.
At least on the iPad, it looks pretty much like this.
Mhm.
But I like this. This is good.
There you go.
Yep, just like in my scope.
That would be tricky. Now, this is a
Rosette?
Hubble picture, and it's rendered in the Hubble palette, which is not red, green, blue, which is what amateur astronomers use for their color scheme. This is a palette that is picked because of the specific elements that they want to look at. And I don't recall them offhand, but it's a little tricky to try and get a RGB picture out of what Hubble captures. It wasn't designed to make pretty pictures. It was designed to give us scientific data. Tim,
No, I'm scratching my head.
you were
Scratching
missing.
my head in wonderment. Well, like about how this would not correlate to hydrogen and oxygen in there. I don't think.
It is.
Is it really?
I don't. Well, they are. It's linked to specific chemical elements.
Yeah,
I
probably
don't
has some
know which
sulfur too.
ones were used in this picture.
Yeah, one of them is a sulfur wavelength that they
Yeah.
do.
Mhm.
Sulfur. Okay.
Yeah.
Would that be the orangish?
Towards
We'd
the
have to research that to know. I don't.
Okay. Okay. This is a neat picture, boy. Wow.
Yeah.
Now, this is a picture of it. This is actually two pictures. This is a red, green, blue picture of it, taken by a telescope here on Earth.
Wow.
And this is an X-ray picture, from an X-ray camera of these regions here. And these red dots you see are new stars that formed. And the X-rays can see through the clouds. They don't see the clouds so much.
Is this a planetary?
No.
No.
It's just a large emission nebula?
Yeah.
Yeah, it's stellar birth.
And the cluster in there has kind of blown a hole out of it, so that's why
Yeah.
it looks that way.
That's why I was wondering if it was, had a
Oh,
little.
because it's roughly circular.
Yeah.
Yeah. No, it's part of a much bigger complex.
Boy,
Just
Isn't-
this little
isn't it-
dot has circularity.
as I recall, we have to use a filter for this to see it really well. And it's actually in a good telescope. It's actually pretty cool.
Yeah.
But it's pretty low surface brightness.
Yeah.
I was just going to mention, Tim, when I was in the San Jose club, one of our members, who is an awfully good observer, moved away to Portal, Arizona. And he said you could see the rosette with your naked eye there.
Oh my God.
And everybody just booed him.
Yeah. I bet.
Well, that central area you said was taken by X-rays. Would it have been different in another medium like
Sure.
ultraviolet or infrared or something?
Sure.
Look at this.
It would have looked different.
That's
Yeah.
amazing.
It'd
Those
clear out all
boxes
the-
outline the X-ray areas.
Yeah,
The
right.
red dots are the bright spots. So if you subtracted out the optical stuff, all you'd have is the red dots.
Yeah.
Jerry, have you imaged this in your?
Yes.
Oh, fantastic. I'd like to see that.
This is not my image.
I bet it's close to it though.
Yeah. So,
So this is the
okay, now
follow-up.
we're going to move on to supernova and novae in particular.
No way. Whoa, look at him.
And this is a neat a graph of historical suspects or candidates for supernova and their estimated time.
Oh,
Can you guess how they estimate the time of them?
Expansion?
Yes, expansion. They take pictures over 50 years between, say, and they see the expansion rate, and then they just crank it backwards, scale it linearly backwards.
God.
Some of them, there was an event, such as this one up here in 1054.
Mhm.
So there were historical observations, and the time that the Chinese, for example, wrote this down, and the rate they get from going backwards correspond.
Mhm.
But they're all in our galaxy, right? Not in other galaxies.
Right.
Yes. Mhm.
I did not realize the Crab Nebula was 1006.
No, it's 1054.
Right.
The Crab?
Yeah.
Yeah, that's when they think it exploded. But it actually exploded before that year.
Yeah.
Why does the Crab have AD 10006?
No, it doesn't. It has 1054. It's the one right next door.
Oh, he's looking below that to the left.
Oh, you're
Yeah.
looking there?
No, below.
Oh.
There.
No,
Keep
two
going
two
left.
over. Go two
Oh,
left.
well, no, that's wrong. Sorry. 1054. It was July 4th.
Mhm.
Huh. Interesting.
Yeah, it's recorded in the Canyon Country in Utah,
Hmm.
northern New Mexico, on walls.
Yeah, they don't have a date for this. Yeah, they've doubled, 10.
Yeah. Yeah, that's wrong.
Yeah.
I
Yeah,
think they've flipped
okay.
a couple of these.
Yeah. Okay, that source is right out.
Yeah.
Now this, they come in different types of supernova and nova. A nova is a white dwarf that steals hydrogen from a binary companion, triggering surface fusion. A supernova is caused either by a white dwarf exceeding its mass limit by stealing from a large star, or a massive star collapsing under its own gravity, a core collapse star. This is the type 1A process where you have two normal stars in a binary pair.
Mhm.
More massive stars become a giant, which spills gas onto the secondary star. The secondary lighter star and the core of the giant star spiral toward a common envelope. The common envelope is ejected while the separation between the core and the secondary star increases. The remaining core of the giant collapses and becomes a white dwarf. This is pre-nova. The aging companion stars are swelling and spilling onto the white dwarf. The white dwarf mass increases until it reaches a critical mass and it explodes, causing the companion star to be ejected away. So the white dwarf does not survive a type 1A supernova,
Right.
but it does survive a regular nova.
And
I
a
really
regular
like
nova
that.
can happen during this process
Yeah,
before the white dwarf reaches that mass limit.
What's happening in the middle square? That big circular that ring. What is that?
That's where they ejected the gas envelope that spread out when they got close to each other.
Okay.
I always thought it was funny that type ones have two participants and
Yeah.
type two have one participant.
Wow.
Well, some type ones don't, but yeah, 1As.
Mhm.
Well, have they collided?
No,
now
No, it's
there's
just dragging
also
atmosphere.
but
core
there's another
collapse
type of type
supernova.
1A that they found now where you can have two white dwarfs that collide and cause this.
Okay.
But we ended up with two white dwarfs, right?
Who's talking?
No, you end up with a black hole and an ejected star, or you end up with just a debris cloud.
Right.
This is neat. I like.
I
Mhm.
like this too, yeah. Except we don't see the lines,
Not a black
the
hole.
concentric circles.
Yeah, it is pretty washed out.
Yeah, there were concentric circles, Jerry, in the talking points,
Mhm.
but that they probably
I never can remember this sequence.
Oh,
well,
just,
Fe is
just go to the
last.
chart of elements,
Yeah,
Tim.
yeah. I mean, I never can remember the burn sequences as they go. When people ask me this, I always get it wrong. But
Yeah,
I'm gonna,
these are massive stars, don't forget, Tim.
yes,
Yeah.
yes. They have to be how many solar masses? Is
Like
it six?
12.
12?
Can you guys
Well, for a supernova.
Yeah.
Don't see it yet. There it is. Now we got it. There you go.
So Tim, our sun is just doing, hydrogen, helium, and probably some CNO, a little bit of a CNO cycle, carbon, nitrogen, oxygen. But boy, it has no way it can go down to iron.
No, no.
Right.
Is nitrogen also Ne?
No, that's neon.
Neon.
It's
Oh,
neon. Yeah, our sun will not be able to make that. But
So
it
to go
does
hydrogen,
precipitate.
helium, carbon, neon, oxygen, silicon, and then
Oh,
finally
yeah.
iron.
But
Well,
there
there's
is some
sulfur also
CNO.
too that's been
Yeah.
left off.
this is a simplified diagram,
Yeah.
Oh,
but this is a multi-shelled star,
Hmm.
like an ogre and like an onion, it's layered. And the iron at the core, when that starts getting made, it just sits there and increases the gravity, but it does not produce any energy. So this is the end stage of a star, and this is the last configuration simplified before it all collapses, because the energy it takes to make iron does not hold the star up against gravity. So it weakens the gravitational pull. Excuse me. It does not fight gravity. So the gravity wins and everything collapses down and then bounces off. And you get a core collapse supernova.
And that's when, if it were Mad Magazine, you'd have a last stage. It would be kablooey.
Yeah. Well, he comes up with really original words for what all those sound effects are.
Yeah, yeah.
What, do you know the number, the atomic number of iron?
26.
Is it 26?
Uh-huh.
So that's as
Okay.
high as it can go in protons inside the nucleus of an atom. Above
No.
that, it's
No. But that's the most stably bound.
Yes.
well, you lost me
So
because
this is starting from that structure we just saw, and it's representing that the influx of mass pulling the star's elements together is now unopposed, and it races down here till it hits a solid core and it bounces off, and that bounce increases, and that becomes the outward explosion when the two waves hit each other. So that's a core collapse. Now this is a type 1a light curve. This isn't in the talking points. I added this later.
Mhm.
But this is used, these are used as distance monitors, because the type 1a all have this exact same curve, no matter how far they are away. So you can measure the peak brightness, and the time starts at the peak brightness. So not when they notice the nova, and not before it when they first observed it, but time zero for our type 1a supernova is the peak, when the peak is reached. Sometimes it's estimated back, but it's maximum brightness. And then this curve is always the same, but it's different it's flatter or steeper. And it depends on where the star is, because if it's farther away with a big Z number, time passes much more slowly for this. So you have to calibrate that. And this is the difference between the peak brightness and days after B max, which is here in a brightness term. That's the delta magnitude. And if you look at delta magnitude, that's the curve that they use to calibrate the time scale for this. And if they normalize the time scale for it being right here with us, the maximum brightness is what they use to do the inverse square law to decide how far away the star is, or the supernova is.
And this is simplified because now they think there's a couple of different type 1A methods, depending on whether it's two white dwarfs colliding or one
Yes.
white dwarf reaching the limit. So, yeah.
Yes, I've simplified this way down for you. And for me, there's curves like this that show this is the B band, which is roughly visible. But there's about 7 or 8 different bands that show different curves. And so with this filter on, this is the one that's used to calibrate the distance. But even this one will be different depending on the exact details of the structure of what caused the type 1A.
But this won't happen to our sun.
That's correct.
No,
No,
this is
no,
not
not
going to
that.
happen to our sun.
In fact, it won't happen to what? Most stars?
That's right.
Mhm.
Only the red giants?
I got to go back to the other
Not red
display
giants, Ronnie.
software.
It has to be what would have been a star that went through red giant phase but left a white dwarf, but it has to be in a binary system of some kind.
Okay, but what happens to the vast amount of red dwarfs
Nothing.
out there?
Yeah, no,
They just age and flicker out?
Yep.
yeah,
Burn
take a long
everything up?
time. They take a long time.
None of them have flickered all the way out yet.
So we're
Do
not,
we still use the type one the type is it a type 1A
Yeah.
supernova as a standard candle?
Yes. That's
Yes.
what I just went over. And there's type 1B, C, and D,
Mhm.
and there's type 2.
Oh wow.
So this is the standard candle one. Takes place in a binary star system with one of the stars classified as a white dwarf. The dwarf accretes material from its larger counterpart, accumulating mass as a result, eventually incites a chain nuclear reaction, culminating in the star reaching critical density when it explodes in a supernova. Beams of gamma radiation can also be emitted. The type 2 is not in a binary system. After losing the ability to stably fuse heavy elements, the star can no longer retain gravitational equilibrium. Thus, the core collapses in on itself. The core rebounds quickly in succession, subsequently releasing the outer layers of gas into space, forming a nebula. After the dust settles, a neutron star or black hole is left behind. Which one will hinge on the star's original mass? You got that? This will be on the test.
can I
Yeah,
ask this?
the type 2 is a supernova, but is this the one that no, it does have a possible black hole.
Yeah.
At the end,
Type 1A, the type 1A does not. The type 1A just blows up.
Okay, okay.
Another dumb question.
yeah, the type 1A leaves no remnant behind.
The picture on the upper left, to me, connotes the beginning of gravitational waves being picked up by those two LIGO
This
stations.
is material ejected.
Oh, it is? It's
Like
not?
that's not meant to represent a gravitational wave.
Those are tidal tails.
Yeah.
Okay. But would it be fair to say that if we ever witness an explosion, a nova, the LIGO detectors in Washington and Louisiana will pick up the waves probably same time?
No. Well, for
They both
kilonova,
go-
yes.
The supernova would be the only one that gives us gravitational waves?
No. The gravitational waves are from kilonovae or from the merger of black holes.
Okay, but a supernova doesn't send them out that much, I guess, huh?
Not to the level we can detect. Yeah.
Got it.
This is a quick photograph of the supernova 1997D seen in NGC 1536 in Reticulum constellation. This is the supernova down here, long way away.
Mhm.
This is a collision sequence for a magnetar-powered kilonova blast. Now, this is a collision between a neutron star, two neutron stars, or a neutron star and a black hole. and it is the likely source of heavy elements like gold and uranium.
So this is the one that would be detectable from gravitational waves because it's massive objects.
Mhm.
Kilonova.
This was observed on May 22, 2020.
Wow.
And I think the first one was 2017,
I think that's correct, if I remember right. Yeah.
but it wasn't a magnetar.
No.
Magnetar powered, electrical, huh? Electromagnetic.
What's that?
The magnetar is all electromagnetism to me for some reason.
A magnetar is an extremely fast neutron star, rotating. So it's got a magnetic moment, and the speed of the angular momentum is magnifying it. Remember, a magnetic field is made by charge that's moving in a circular wire, for example, in the simplest case.
But kilonovas are the biggest blasts.
No,
They're not.
No,
they're intermediate between novae and supernovae.
right, in terms of their output of light.
Okay.
Okay, in hearing, maybe I shouldn't ask this. In hearing about how stars form or born, at some point the gas comes together and they start rotating. Here you can see these neutron stars are really rotating fast, and they get faster and faster. What causes that rotation? Is it
Conservation of angular momentum.
Yeah, the same thing that makes a skater speed up when she pulls her arms in.
Or makes a hurricane.
Conservation of angular momentum.
But they have to be spinning to begin with, right?
They're orbiting each other. They also have spin on their axes too.
Okay. Okay.
But yes, it's a closed system.
Okay.
Nothing's coming in to add angular momentum by bouncing off one of the participants. So as they get closer together, they speed up.
Okay. All right.
It's pretty basic in the universe, Tim. It drives me nuts too. Everything is spinning.
Yeah.
Okay, now we're going to look at something in Leo. This is 11 o'clock at night. We're staying up later. This is R. Leonis. And
Wow.
it is a giant red star that's shedding its outer layers. It's a dying star, and it's not going to be a supernova.
Really?
This is your case of they don't all blow up.
Maybe it has a partner like Betelgeuse.
No, this one doesn't have, we don't have a really close picture of it. It's not real close like Betelgeuse is, but an artist's rendition is shown here. And here it's just shedding material, and it will do that until that energy goes away. It's also a variable star. So it goes between 11th magnitude and 5th magnitude. So you can see it sometime right up in this range with your naked eye. But at these times, what is the period of it? Is it, let's see, this is under 1 year. So it's about 300 days, it looks like.
It says 312 in the notes.
Okay, good. Thank you.
Light curve.
Now we come to the most interesting and the most challenging thing about this. And the next section is all speculative. But I thought you'd be interested in it because this is speculation among physicists as to what they think might be happening with recent James Webb Space Telescope observations of the very early universe.
And I think they found a better description since this, but yeah.
Okay, well, this is one in, I think it was Wikipedia or space.com. So these things, but the thing is not that these are the final answer, but that this is a discussion. We're witnessing a discussion between the big boys about what they're going to try and do with their math to explain these things. So we have the issues to be looked at is the surprising overabundance of supermassive black holes in the early universe. They don't accrete. They can't accrete. There's not enough time to accrete like they do later, supposedly. The unexpected existence of a blue monster. which are galaxies that are very, very large and very early, and the so-called little red dots, which very creatively has been abbreviated as LRDs.
And I think it's the LRDs that they now think are nascent black holes shrouded in dust.
Yep. Okay, so and the explanation, there's a single explanation that we'll start with the little red dots. The that and Chuck's what he has said, right, I've seen that too, but that wasn't in this article. And so this I lost
all
train
the
of
same
thought.
picture.
This is about 1 billion years after the Big Bang.
Okay.
And they these rest on what they're calling dark stars, which are a hypothetical object that was proposed to be common in the early universe, rather than being powered by nuclear fusion. The normal stars are. Dark stars are thought to have been powered by the annihilation of dark matter particles. Dark stars refers to the source of these stars' energy. They would have, in fact, been incredibly bright. So these are some of the little red dots close up.
Huh. A dark star to me was a euphemism for a black hole, wasn't it?
No, that's a black hole that's different. This is a proposed dark star that addresses these things. Now, this is an artist's process of a dark star type thing. This has a black hole in the center of a star, and it has a star around the outside. It's a spherical accretion disk. It's just so dense it can't get into the door. It's like an auditorium full of people and someone yells fire, and there's only one little exit door. Everybody's going to jam there, but they can't get through. They can't get through the exit.
Hmm. But that doesn't happen today. We don't get black holes in the middle of stars.
We don't know.
No, we don't know. You couldn't tell. Someone even proposed that we have a small black hole in the center of our sun. I think that's highly speculative, and the black hole is not needed to account for any of the physical phenomena we see going on with the sun. So, like a god, if it doesn't have any proofs for it, I'm just not interested.
Like a god. Interesting. This is an artist's rendition, of course, we're looking at.
Whoops.
You got to tell us more about
This is from James Webb. This is the near IR spectrum, prism spectrum of what's called the cliff rubies. The orange points show, oh well. Anyway, this is spectroscopic evidence for one of these red dots. The slit of the spectrometer is here. We see the curve. This is called the cliff. And the cliff. So these are, lift the conclusion off. So this is the spectrum of a little red dot. And this is a size comparison of a quasi-star, which was referred to earlier in the article as a dark star, formed with either dark matter at the core or a black hole at the core. And these things would be very large. They are not they don't exist now in this part of in this age of the galaxy.
These are those, what they refer to as those really early, very supermassive stars.
Yes.
Yeah.
Well, yeah.
Well, then what were the red dots?
The current thinking is that the red dots are black holes, in kind of intermediate mass black holes that are still shrouded with stuff that is falling into them, and that's why they appear the way they do.
Oh,
Apparently these two squares are the same part of the sky looked at by two different telescopes.
This
Yes,
is
yeah.
a James Webb picture of the very early universe. And here we have what blow up of what the James Webb sees, a black hole and a host galaxy. And this is what Chandra sees, a black hole over here. Same black hole.
Wow.
In
What was Chandra's?
Chandra's X-ray.
Yeah, Chandra's
X-ray.
X-ray.
Okay,
It means moon.
Yeah.
it does. Okay.
So
I want to
these,
hear more about blue monster galaxies. Are they in there
I'm
too?
not making this very clear, I know, but
no, this is tough stuff.
Oh, this is all conjecture, Tim.
oh, let's see, go back this way. Oh, nope. Anyone fall over yet? Okay.
What
Now,
does the word cliff
the
come?
key point is that dark stars, also called quasi-stars, are a hypothetical object. Could be a small black hole with gas dust around it, but it is used to explain it's a single solution to three puzzles. The puzzles include the surprising abundance of supermassive black holes in the early universe, the unexpected existence of blue monster galaxies, and the so-called little red dots science have been finding. So dark stars are hypothetical objects that are proposed to have existed in the early universe rather than being powered by nuclear fusion. As normal stars are, dark stars are thought to have been powered by the annihilation of dark matter particles. Dark refers to that source of these stars' energy. They would have, in fact, been incredibly bright. So they're not dark stars in the sense that they're dark. They are dark because the energy powering them comes from dark matter.
Oh, wow.
Well, I didn't think there was an interaction between regular matter and dark matter.
There isn't, but the dark matter in some models interacts with itself, potentially, and annihilates. It's its own antiparticle.
Now, if dark stars existed, they would have been capable of forming in the universe before ordinary stars could have formed. When ultra-dense cores of dark matter are exhausted, it is theorized that the dark stars could collapse and form massive seeds for supermassive black holes. These seeds would be much more massive than the black holes formed when even the most massive stars run out of fuel or nuclear fusion. This, coupled with the fact that dark stars could have existed before normal stars, would allow supermassive black holes to form much faster than the standard chain of black hole mergers thought to create supermassive black holes now. So remember, this is theoretical.
Yeah,
It's just
it sounds like somebody's trying to.
Yes, they're trying to find a rationale for how these things could all fit together.
Yep.
That's what they're speculating about. So we are witness to cosmologists' speculation. And I put it in there as like the initial stage of science.
But one of the big questions of astronomy is, where's the antimatter? It's all matter and there should be equal amounts.
That's okay. That's a tough question.
Well, Chuck just described wimps versus anti-wimps wiping each other out, and that's
No. Well,
Axions,
yeah.
axions. Oh, wimps, axions, they don't know.
No, we don't know. There's a lot we don't know, but we're getting more specific about what we don't know.
Yeah. And the axions are proposed to be their own antiparticles. So that,
Yes.
but normally they're collisionless.
And
Cold.
somehow we make antiparticles and
Well, that's a
colliders.
different thing. That's a
Yeah.
different thing.
I
You
know,
know, Ronnie, the way I'm thinking of this is like this: is that sometimes you kind of come up against a wall with the physics, with the math,
Yeah.
and sometimes you come up with these science fiction ideas, and those science fiction ideas sometimes they're little breakthroughs, and they really they hold water. Of course, the water might be hard, hard water.
So
The water.
my secret theory is that there are aliens out there and they have mental telepathy with us, and they pick one or two people on Earth to give them a very advanced idea. And the guy gets this brainstorm and he writes a science fiction book.
Yeah.
And
Yeah,
aliens do it to seed our
yeah,
future development.
yeah.
Okay, now
Much
that
more
was
efficient than crop circles.
what I read first was the first of 3 steps in the argument. The second step is these black holes aren't the only unexpected thing the JWST has been detecting in the early universe since it began observation in 2022. The Space Telescope has been spotting extremely bright, ultra compact, and incredibly dense galaxies that lack an abundance of dust.
Huh.
These are categorized as blue monsters. These are galaxies that no cosmological simulation or model of the formation of the earliest galaxies predicted in the existence of the prior era to have been able to answer. The team suggests that these blue monsters aren't galaxies at all, but are instead incredibly luminous dark stars that, because of their brightness, are being mistaken for entire galaxies with populations of stars packed into a region no wider than a few hundred light years.
A large star cluster.
So that's theory 2A subgroup B.
Whoa.
Okay, wait, now the last one, the little red dots, though much dimmer than blue monsters, are also notable for how compact they are, requiring an almost impossibly dense packing of stars if they are indeed galaxies. The other puzzling characteristic of little red dots is they emit weakly in ultraviolet and don't seem to emit X-rays at all. The team argues the collapse of dark stars that have exhausted their dark matter could result in black holes that are still surrounded by layers of stellar material, Chuck's dust. And that could
Yeah.
have the effect of semi-obscuring ultraviolet light and completely obscuring X-ray light in a way that the dust holes
Halos.
galaxies alone cannot.
Is it possible to obscure an X-ray with dust?
Yeah.
What's
Really?
that?
Huh.
Well,
Okay.
the interesting phrase there, Mr. President, was exhausted their dark matter, like we're using it up.
So
Because
for now, dark stars remain purely hypothetical, though some observational evidence is beginning to emerge. Nevertheless, this research presents an intriguing attempt to solve 3 cosmological puzzles with one mechanism.
Or a new movie.
What?
Or a new movie.
Yeah,
You're-
right.
yeah, Ronnie,
The results are in a paper published in December 2025 in the journal Astrophysics and Cosmology at High Z, which means
Ronnie, when they say these dark stars have exhausted their dark matter, that's because this one version postulated for dark matter is its own antiparticle.
yeah, I've heard that.
As they collide with each other, they go into pure energy, and now there's no more mass there. Okay, the energy gets radiated away, and so gradually these things eat themselves up.
Huh.
But so when you say pure energy, it becomes light waves, and that's where the brightness comes in. When you think,
Yeah.
They will also radiate energy away as gravitational waves, but yes, it's probably primarily light.
I'll tell you what it radiated away here. My understanding all of a sudden went poof.
This discussion is a very interesting precursor. It may all be wrong. I doubt it. May all of it need to be modified, which I don't doubt. But it's a very interesting topic to think about. What it tells
That's good
me,
conclusion, Jerry. I think that's good
was a very
conclusion.
different zoo than what we have now.
But it's nice that it fits.
but the one thing that's missing is the time element. This isn't like those 5 proto galaxies that were only 300 million years old. This is later. When you think a million years or a billion,
Some of this stuff, yeah, is quite a bit older.
older or younger?
Well, quite
Farther
a bit
back.
later in the history of the universe.
Gotcha. I
Yeah.
understand. Okay. So it's not like those five strange galaxies.
Well,
What are they
those
doing
six
there?
little red dots are part of this.
Wow. Little red dots. And little red dots are not red dwarfs.
No,
That's in our
no, no.
galaxy. That's a totally different thing. Yeah.
Yeah.
Now, is this going to assume a flat universe, a round universe, or is it not going to assume that at all?
I think they started with, when Einstein came out with his general relativity theory, the first solution was for a totally empty universe, no mass at all. You know, they try and do the easy things. That's where they come up with a spherical cow joke in physics.
Mhm.
You simplify it down. So assume a cow is spherical, and then you do the math.
Yeah.
They've been adding, now with computers, we can do a lot more complicated math and stuff. But yes, they're trying to make it as simple as possible.
I always wanted to build a scope that was like a universe scope and have kids come up to it, and I have a hidden camera behind them. So when they look in the eyepiece, they see the back of their own head, and then tell them it's circular.
Yeah,
And this
the
proves it.
idea, the shape of the universe, as far as we can see, it appears flat, but it could be just very big.
Yeah. That's what my gut tells me.
All right. So this picture of a black hole inside a star has its own little accretion disk.
That's what they're indicating with this little ring in there. There's the black hole, there's a little accretion disk. And this is really an accretion sphere. They can't get at the disk yet.
Man, I mean, this is cool stuff.
I kind of thought black holes were instant. The minute you're in the vicinity, you're sucked up. You can't exist around it except in a fast going accretion disk.
Well, according to what's his name, Brian Cox, there is no space inside a black hole. It's only time. It's twisted time, space-time, to where it's only time. And the singularity at the center of a black hole, if there is one, is not a point in space. It's an instant in time. Because actually time stops at the surface of at the event horizon.
There's even some wild theory that we're inside of a black hole.
Yeah, that's not so wild. I can easily conceive that.
Really?
Yeah, whenever you're inside, you could hold a black hole in your hand. Quite dangerous, but if you did, the small one, inside, it will create its own metric, its own scale metric. So what is a light year inside your black hole is very, very different than what we consider a light year here in our black hole.
Right.
So it redefines what length is inside. And therefore, it's
because of the time distortion too, since they're roughly equivalent.
And it's like the TARDIS. If you've seen the what is that?
Doctor Who.
Doctor Who, yeah. It looks like a phone, a police phone booth in England.
Yeah, right.
But it's bigger inside than it is outside.
Yeah, that is a great. What do they call that? It's very, very popular. I can't remember what they call that in England, the Doctor Who thing.
Yeah.
Somebody plays Doctor Who. It's a big deal.
It's its own cult.
Its own cult.
All we got to
The
do
ideas
here
are clever. The special effects are laughable, but it's quite good.
We had some folks at Westmont. There were two particular who were like extreme Star Trek fans. And they were talking about the merits of the various series. And this one guy was saying, "Oh, yeah, I've watched that entire series 32 times."
Well, as far as being in a black hole, just ask Matthew McConaughey, I guess. Gentlemen, I think we reached the end. And of course, Tom Whittemore dominated everything. Thanks a lot, Tom. Good to have you on board, all of you.
Yeah.
We're going to start our 60th year in about a month and a half. It's 1st of March. And we'll see you at different things. What's coming up, Star party wise? Chuck, anything?
What have we got? We've got Telescope Tuesday tomorrow night, and
Oh, it's Telescope Tuesday, as well as online workshop,
yeah,
same
There's
time.
a-
outreach wise, it's Telescope Tuesday out of Community Rail Marketplace, and then the rest of the month is just school events.
Yeah.
There's the little calendar Tom gave me for
All
math.
right, number
That is
250.
backwards. Okay, so that picture is backwards because this book is too.
Well,
For crying out
you're
loud.
messing with your own background display, so we really can't see the book.
Oh yeah.
Blue screen, whatever.
It's a calendar.
All right, number 257 next week, gentlemen. In the meantime, just like Mork used to say, Nanu Nanu, we have our own way of saying farewell.
Hasta
Live long and
Nebula.
prosper.
Nebula,
Thank you,
everybody.
guys.